supplied to a unit mass of a body, the amount of heat supplied to a unit mass of a body to convert it from its original form to another form. What is the SI unit of specific latent heat? The unit is joule per kilogram. Mathematically, for latent heat from the amount of heat supplied is Q, which is equal to mL. Okay, that is the heat. Okay, it's equal to mL. Our latent heat is L. Let's make L the subject of the formula. We are going to have Q over M, and this is joule, the unit. This is kilogram for mass. When you take this together, we have joule per kilogram. Joule per kilogram. And that's the unit of latent heat, which is the amount of heat supplied to a unit mass of a body to convert it from its original form to another form. And the latent heat, it can occur at melting or at boiling points. Melting is ice. Boiling, that is at vapor. Ice and vapor. Because melting, that is from ice to water. Okay? Then for boiling, that is from water what? Vapor. Let's take note of that. Then we are going to consider using the diagram. Let's use the diagram to see how heat it is being gained. Using the diagram above for ice block, heat is gained in two ways. Look at the first diagram. This is ice block. This is the mass of ice, Mi. This is ice block at 0 degrees Celsius. This is the temperature of this ice block, 0 degrees Celsius. By the time this ice block is being melted or dissolved, it dissolves to ice water. This is the mass of water. Still in 0 degree what? Celsius. This ice water, the temperature rises. By the time it gains, because if you look at the temperature from the ice block and the temperature at ice water, they have the same what? Temperature. By the time we check it, the temperature has rise or has increased from 0 degrees Celsius to 20 degrees what? Celsius, which means there is a rise in temperature. Okay, so at this time, when the temperature still remains the same, the quantity of heat is mL. By the time the temperature has now increased from 0 degrees Celsius to another level of temperature, the quantity of heat will be mCT. And that is the difference. That is what we want us to get. So if we are to calculate the total quantity of heat now from ice block to this cold water, it's going to pass through two stages. This is going to be mL when the temperature has not changed, but there is a change of the substance, plus mCT when the temperature has rise from initial temperature to another level of what? Temperature. And that is what we have been trying to solve by the time we are trying to do something on specific heat capacity the other time. When we are doing something on quantity of heat, we also go through something like this, and that's what we are talking about. As we continue, so in this situation now, the total heat now will be heat for change of state, which is mL, because there is a change of state from ice block to ice water, which is mL. Total heat will now be heat for change of state plus, then we are going to have heat for increased temperature. So that will be total heat now, which is mL, heat for change of state, plus mCT, heat for increased temperature. When the temperature increases from 0 degrees Celsius to 20 degrees Celsius, but still remain the same substance. And that's what we are talking about. We are going to consider for vaporization. Let's consider the diagram above. We want to consider from boiling water to steam. But normally we have a water, ordinary water at this temperature. It has a lower temperature, just like ordinary water. Okay? Let us assume we suspend this water to a source of heat. Let's say we have a source of heat. We suspend it under a source of heat. The water begins to boil. Okay? Before we know it, the water will start boiling. And by the time the water is boiling, the temperature will change from 30 degrees. Let's say, for example, it gets to 100 degrees Celsius. Still at mCT. Because in this case, we are not dealing with ice. We are dealing with ordinary water at a particular temperature. And water will have its own specific heat capacity, which is C. T is the temperature. Mass is M is the mass of water. By the time it gets to this temperature level, then before we know it, vapor begins to come out. So from water to vapor, which is steam. But still at this same temperature, at boiling water, 100 degrees Celsius, at steam, 100 degrees Celsius. So how are we going to calculate the total amount of heat energy that operates from this level to this level? We are still going to have Q to be equal to mCT plus mL. mCT, when the water changes from 30 degrees Celsius to 100 degrees Celsius, you still have this. But by the time it now gets from boiling to steam, the temperature still remain the same. We have mL, and that will be the total heat or quantity of heat that will change these substances from this stage to this stage. And that is what we are talking about. So, for fusion, that is, we are talking about melting. And what is that? That is from solid to liquid. And that one is a gain of heat energy. That is the gain of heat. By the time the substances change, it changes from solid to liquid. That's gain of heat. Then what about vaporization? Vaporization is from liquid to vapor. That is loss of heat. Let's take note of that. Condensation. That is vapor. That is from vapor back to liquid. That is gain of heat. Then freezing. Freezing is liquid to solid. It is also a loss of heat energy. Then sublimation. That is from solid to gas. That is also gain of heat. Let's take it one by one. Melting. Melting, when it occurs, takes solid to liquid as a result of gain of latent heat of fusion. The gain of heat we are talking about here is the latent heat, which is our Q. Okay? But our L can be latent heat of fusion, it can be latent heat of vaporization, depending on the one we are treating. Okay? So melting, it occurs, okay, takes solid to liquid as a result of the gain of heat of latent heat of fusion or melting. Then we are going to consider the melting point of a solid. This is the temperature at which solid changes to liquid at the melting point. Temperature at which a solid changes to liquid at the melting point. Let's take note of this. Melting point is affected by pressure and impurity. Melting point is affected by pressure and impurity. Let's take note of that. Then, increased pressure causes melting point depression. When you increase the pressure, it will cause melting point depression. Then, increased impurity. When the impurity increased in the substance, it will cause the melting point depression at the same time. Okay? What about boiling points? Boiling point is the temperature at which the saturated vapor pressure, we call it SVP, saturated vapor pressure, SVP, of the liquid equal to the external pressure on liquid. Boiling can occur at a given temperature which corresponds to the external pressure. Then boiling point is affected by, number one, pressure. That is, the boiling point can be affected by pressure. Boiling point changes as pressure applied. That's one. Then boiling point is also affected by impurity.